So we're going to continue this week with looking at the differences between the different operations with our polynomials here. So today we're going to focus in on multiplication versus subtraction. So let's hit multiplication. It's the more straightforward one because it does use a lot of the ideas of just simply multiplying with fractions. We don't need a common denominator. With subtraction, we're going to need one. We have something we can use, which is cross division or cross simplifying with your multiplication. We don't have that with our subtraction here. So let's throw someone at you here. Let's go after x squared and plus 2x. We're also going to get some of a little factoring review in here as well. Plus 1 over x squared plus x minus 6, and then times x minus 2 over, and then x plus 1. Okay, so the big thing here, the strategy is to always factor first. Anytime we're trying to clean things up, simplifying, factoring is the way to go. So let's see if you can factor what's on the left-hand side there. On the right-hand side, they're just binomials, x minus 2, x plus 1, no factoring there. Let's see if you can factor the other side. Hit that pause button. All right, so the main thing that's going on here is because it's just an x squared, yes, I just need two numbers that multiply to 1 and add to 2. So that would be 1 and 1. So there's my factored form. Again, I see just the x squared. That means I can jump right to it. I got to multiply to negative 6, but when I combine, I need to get a 1. So again, as I've said before, is like just focus on the 6. So 3 and 2. And I can do 3 minus 2 to get a 1. So 3 minus 2, so that means a positive 3, and then a minus 2. So there's your negative 2 that you're looking at. All right. And then, yep, we're multiplying. We can just bring down those binomials. And now we're looking at our cross division here. And so because they're the exact same, we know when we divide two numbers, 7 divided by 7, 1. 8 divided by 8, 1. 32 divided by 32, 1. That's why we're able to just simply, in a way, cross them out. We are simplifying here. So what are we left with? Well, all we've got is x plus 1 over x plus 3. And we're done. That's it. So simplifying with your multiplication of your polynomials, hey, factor, what can we get rid of? And then you're just kind of stuck with what's left over. So not a lot of action that we have to really end up worrying about from a standpoint of multi-step. Let's get into our subtraction here. And this is where we start to see a little bit more action that we're going to have to end up dealing with. So with a subtraction, we are going to need a common denominator. So we're going to use this problem of 7x plus 6, all right, over 4 minus 9x minus 3 over 7. So the big idea here is there's nothing to factor. All right, and so this is where we could just jump into our technique of, to add or subtract with fractions, I do need a common denominator here. So I can go through them, and we've got ourselves a winner. Yes, 28. Now, it's not because it's 7 times 4. It's more about as we go through the factors, that is the first, as we go through their multiples, that is the first one we have in common. Remember, if you can't find something in common, then yes, multiply them together. That will always give you a common one. Just doesn't always give you the smallest. All right, so we can see here is we're going to go back to our days of subtracting with fractions. And what I multiplied? Well, I multiplied by a 7, which means I have to multiply everyone up in that numerator by a 7. So there's a 49x plus a 42. All right, over here, what did I multiply the 7 by to get to a 28? Well, that's a 4. So I got to multiply everyone up here by a 4. So that is a 36x and then minus a 12. Now, what I have to be careful about here is this subtraction sign, because this subtraction sign does go with everyone that's over here. So 49x minus 36x, all right, that'll give me a 13x. 42 minus the negative 12. Well, double negatives, that becomes an addition. So we're doing 42 plus 12. So that's a 54. For some of you, you're going to want to go ahead and change it to an addition sign and then realize it'll end up changing these signs here. Some of you are used to seeing that. If that's the case and it makes it easier for you, go ahead and do that. And then all over our 28. The only way I could simplify here is if I've got a number that all three of these can be divided by, and there isn't. Instead of it being a 13x, maybe if it was a 14x, then I can divide them all by a 2, and then that would give me something to do there. But that's it. So the big thing here is what you've got to remember is common denominators versus simply, hey, let's simplify. So what ends up happening if we don't if we got the polynomials though? Because here we just had like a 4 and a 7, like that was it, not a whole lot that's going on with it. Well, let's do a very similar problem, but just show you the changes that can end up happening here. So let's look if we have binomials in the denominator. So let's go back to a very similar problem that we just looked at. Let's go ahead and let's do that 7x plus 6, but then let's go x plus 4. And then let's plus this time. All right, less to juggle with here. And then we'll make the number smaller. How about a 2x plus 3? And then over here, we're going to use an x plus 1. Again, keep it lighter. That's here. Okay, so we do need a common denominator. Now, the issue before we talked about was, hey, just don't multiply them together. Let's find someone. Well, with binomials, you don't have that option. The only common is when you do multiply them together. So much like the 4 and the 7, we're like, listen, it'll work. That's what you always want to go to. So our common denominator here is going to be an x plus 4 and an x plus 1. I should say times an x plus 1. And then same thing over here. It's going to be the common denominator of x plus 4 and the x plus 1. So just like before when we saw the 4 and the 7, we just multiply them together. That's what we do right here. So we can visually see, well, what do you multiply by to get to there? Well, it's kind of like, what are you missing? And there, it's an x plus 1. So I have to take my 7x plus 6, and I need to multiply it by x plus 1. Yeah, it gets some heavy lifting that's going on here, and you'll see more here in a second. So what do you multiply by? Well, again, it's what's missing. I need to multiply by an x plus 4. And so now we're stuck multiplying it out. Now, again, the previous problem was much nicer, just a little distributive property. Well, now we're multiplying two binomials together. So here we go. 7x squared, as we multiply here. 7x, 6x, and then your 6. All right. See if you can simplify that, and then see if you can get going on the other side over there. In fact, then see if you can combine everything together. Hit that pause button. See how far you can get. All right, so that denominator is still the same here. Again, just coming along for the ride. And then here we go. 2x squared, 8x, 3x, and 12. And again, all coming along for the ride. Now we can see our common denominators, and so just like before, we can add people together. Remember, we can only add together our like terms that were there. All right. Oops, looks like I lost an exponent right there. All right, so here we go. So the 7x squared with the 2x squared. There's a 9x squared. The 7x and the 6x, 13x. The 8x and the 3x, 11x. 13 plus the 11. All right. Ooh, 13, 11, 24. Yeah, plus 24x. And then the 6 with the 12, there's your 18. And then all over our x plus 4, and then our x plus 1. And there we go. All right. Don't really get into the factoring down here. It's something where it's rare if they ever end up simplifying out. So it's something to be aware of. At the same time, that's something on a test I would be like, if I've got time, I'll come back. and I'll see if I can factor you or whatever the case may be. But yeah, nothing wrong with just simply leaving it alone and taking from there. We'll see you later.